Okay, Bismillahirrahmanirrahim. So this is the video for your quiz 2 solution. Okay, so this is a question. The question that was given to you is find the Norton and Thevenin equivalent circuit to the right of terminal AB. So this one here, so it means that what you have to produce is basically you have to produce a circuit where you have your VTH and your RTH. So you have your VTH and you have your RTH, and your I Norton, okay, you can use the equation VTH over RTH. So those of you, however, if let's say you prefer to do Norton, then you will do that one there. Then you will have I Norton, R Norton, and then you find your VTH by using VTH equals to I Norton multiplied by R Norton. So which way you prefer, you want to do Thevenin first or you want to do Norton first, it's up to you. Okay, so for the solution, I'm just going to stick with doing Thevenin equivalent, then I use the equation. Okay, I will be using this equation here to find my I Norton to solve Norton and Thevenin equivalent circuit. Alright, so here goes. So as mentioned, okay, you need to find two components, VTH and RTH. So if you remember from the mental notes that I gave you, okay, that I have given you, so if you are doing RTH, especially for question with dependent source, alright, yeah, forgot to mention, here is the IX. Okay, this is where the IX is. Okay, so if, for example, this question here, there is a dependent voltage source here, so you know that you're going to have to add the voltage source at the open, isn't it? The open circuit here, the terminal AB. Alright, now for RTH, there is a dependent source, you know that you have to add the voltage. Okay, the 1 volt voltage or any voltage that you prefer. So I'm just going to copy that circuit here. Oh no, I'll put it small one here. Put a small version so that I can have a reference to it. Another one, I put it here. Make it smaller, just for my reference. Our reference, okay? So I have to re-sketch my circuit. So RTH, you turn off all independent sources. You have to turn off all independent sources, but you can never turn off dependent source. So with that, your new circuit will look like this. So that's the 5 ohm. Yeah, forgive my ugly 5 ohm. And then that's the 8 ohm. 6 ohm is over there. Now turn off voltage, replace with a short circuit. Brilliant. If you said that, it's good. If you didn't remember, so you just have to practice more and then it will stick to you, inshallah. Then that one is a 6 ohm. Okay, that one is a 6 ohm. And then you cannot turn off dependent source. Yep, turn off, current become open circuit, hence that's the open circuit over there. Okay, 6 ohm, my ugly dependent source, that is IX. And then that's my IX over there. Okay, and then that's, I'm just gonna put the value 8 and 6. Okay, so first step is turn off all independent sources. Turn off voltage source, become short circuit. Turn off current, become open circuit. Next step is you have to add, okay, the voltage source. Then it's up to you what value you want. I'm just going to stick with 1 volt. Okay, we have discussed, we have shown you that if you use any value, you will still have the same values. And then my I naught is over there. Not cute. Let me just write it back again. So I need to find this one here, I naught. So what is this I naught? So I know that my RTH, given that I have a dependent source, my RTH equals to this 1 volt here, 1 volt divided by I naught. So now I need to find my I naught. Okay, that's number 1. So when you look at this circuit here, okay, I have tried to actually test more of your understanding. Okay, so if you have noticed, okay, this is actually becomes a short circuit. When there is a short circuit and there's a resistor, in this case 2 resistors, 14 ohm, 8 and 6, plus they are in series, the 14 ohm is in parallel with the short circuit. Okay, I hope you actually notice that this resistor of 8 ohm and 6 ohm can be ignored because they are connected in parallel with short circuit. Okay, so I'm not sure if you have noticed that. I haven't skimmed through your answers. Okay, so that one there. So let me just resketch it. I know that I don't have to resketch it, but just to let you see the final outcome of the circuit. Okay, basically your new circuit is this. So you only have left with 2 meshes. I know a lot of you like mesh, so I'm just gonna stick with mesh also. Okay, so basically this is what is left out of that circuit. Alright, so now I'm going to do mesh. Step number 1, label with imaginary current. Okay, so there are 2 meshes. Step number 2, I'm just going to apply mesh 1. Okay, so you're going to do negative 1. I'm going to see the negative 1 first, and then I'm here. I have plus 5 I1 minus I2 equal to 0. Okay, and then what's next? I know that I have to simplify. Okay, so 5I1 minus 5I2 equals to 1. Alright, then that's mesh number 1. How about mesh number 2? The same thing. So I'm going to go here. 5I2, oopsie, minus I1. And then I'm going down, up, I'm going up, I meant 6I2. And then I see the negative sign first, negative 8ix equals to 0. But what is this Ix again? Ix is here, Ix is here. So if you notice, what is Ix? So taking into, so if you look here, what is this Ix? From here, you know that Ix is in the same direction as I1, isn't it? If we go here, yep. So Ix equals to I1 minus I2 equals to Ix, isn't it? So I2 is going upward, opposing the direction of I1, which is equals to Ix. So substitute I1 minus I2 here. Let me take a different color pen. So 5I2 minus 5I1 plus 6I2 minus 8I1 minus I2 equals to 0. So after you substitute that, you will get, let me see, negative 5, that is negative 8, gives you negative 13I1. So you have 5I2 plus 6I2, that is 11I2, plus, minus is plus another 8I2 will give you 19I2 equal to 0. Okay, so you plug into your calculator, I1 equals to I2 equals to, where's my calculator? So I'm just gonna put into my calculator, 1, 2, there's 2 only variable, I1 and I2. First one is 5, next one is negative 5, and then 1. The next one is negative 13. You put into your calculator. I know, I'm so, yeah, I should actually install that, isn't it? Desktop calculator for you to actually see. And then plus 90, and then a 0, you will be getting 0.633 ampere as well as 0.433 ampere. Okay, now can you find I naught? What can you find I naught? Yeah, definitely yes, you need to find I naught in order for you to find RTH. So what is your I naught? So from here, you know that I naught equals to I1, I naught equals to I1 equals to 0.633 ampere. Now can you find RTH? Definitely you can. So what you have to do now is you have to take this value here, you insert it here, okay, then 1 over 0.633. So 1 over answer. 1 over 0.633. We'll be getting 1.58. Don't forget your unit ohm. So just like that, you have completed getting your RTH. Okay, so now what do we do next? So we already get our RTH. We already get our RTH is equal to 1.58 ohm. Now I need to find my VTH. Okay, so VTH, the mental note is go back to the original circuit. Go back to the original circuit and solve the V open circuit, and then solve the V open circuit. So there is an open circuit, so you don't have to worry. So that is your VTH. And I'm just gonna put the IX back. Yeah, forgive me. And then what do you notice? Straight away, what do you notice? You notice that, in fact, madam, VTH equals to the voltage across 5 ohm. That is correct. So if you see that, good job. So if you haven't seen that, again, more practice. So inshallah, you will be able to see that. So VTH is in fact the voltage across 5 ohm. So I'm just going to put that equation there, where VTH, straight away from the circuit, you know, is equals to 5Ix. Alright, next. Let us do this. First step, I'm gonna do mesh again. So I1 there, that means just make that SI2 and that one SI3. And what do I do next? Yep, if you notice that, spot on. If you said, madam, isn't this a super mesh question? That is correct. When there is a voltage, when there is a current source in between, when there's a current source in between meshes, this is a super mesh question. Again, I made this question tailored to actually see your understanding. So because I know a lot of you will do mesh analysis, so I put in a super mesh to see if you're able to actually capture that. So alhamdulillah, if you manage to get that, alhamdulillah. Alright, get me black pen again. So let us just do for the super mesh. I'm just going to start with here the 5 ohm. So it's 5I1. So 5I1, and then going down here, that's plus 6I2. And now you see the minus sign first, minus 8Ix. I'm going up here. Now this one here is plus 6I2 minus I3. Or I know some of you like to do this. Just going to write it there. Minus 6I3, and then I'm here plus 8I1 minus 8I3 equals to 0. Alright, good job. So if you actually see that, alhamdulillah, it means you remember your super mesh. Okay, and then let us simplify this. Oh, we have Ix, where Ix equals to what? Let me just put here. Where why not I not put it? Just put the equation. So I'm just gonna put Ix equals to, what do you think? Is it equals to I1 or negative I1? Are they in the same direction? I1 is going upward. I1 is going upward. Okay, Ix is going downward. So you notice that it is in the opposite direction. Ix equals to a negative I1. So substitute this into this. Okay, I know you cannot do this, but I can. So I'm just gonna do minus minus positive, Ix equals to I1. There you have it. So after I simplify that, after I substitute, so 5 tambah 8, 8 plus 8 plus 8, okay, 16, 21, 21 I1, I2 6, I2, this is also 6, okay, that's it, plus 12, I2, how about I3, negative 6 plus negative 8, negative 14 I3, anything else? Nothing else, equals to 0. So when there is a super mesh, there must be one equation by Kirchhoff's current law. Now here, we are here. So this one here, remember, if you are unaware, I said I want you to actually like draw it, and then you put your current I1, and then you put that current there I2, isn't it? So I said it's good habit to actually have that. So, but if you already can see, you can just write it away. It's the same direction as I1 going downwards, so I1 minus I2 equals to 4 ampere. That is your next equation. This is your first equation, this is your second equation. Oh, pen merah, lupa nak tukar pen. Alright, next one, mesh 3. We have 3 unknown variables, actually 4, but we have to have at least 4 equations. So mesh number 3 is the last one. I'm going to start with this, minus 6 plus 8 I3 minus I1 plus 6 I3 minus I1 equals to 0. And then you do 8 and 6, that one equals to minus 14. 14 I3. Apa ni? Sorry. This is actually, sorry. 8 I3 minus I1 plus 6 I3 minus 6 I2. Barulah betul. Let me put 8 and 6. That one is, no, we do I1 first. Okay, 8 I1 and then 6 I2 minus 6 I2 and 8 3 plus 14 I3. I'm gonna put the 6 over 6. That is your third equation. Okay, you put into your calculator. Now this time you have to make sure you take 3 unknown variables. So A1 is 21, and then 12, and then minus 14, and a 0. The next one is 1, negative 1, there's no I3 there, and the 4. Last is negative 8, negative 6, and 14. Last one is 6. You should be getting I1 equals to 1.58, I2 equals to, don't forget your unit, negative 2.42 ampere, then I3 you will be getting 0.29. So if you tanya madam, boleh tak saya tak nak tulis semua, saya nak I1 je. Boleh, tak ada masalah. Alright. So is it done? Not yet. We want VTH lah. So VTH, you plug into your equation. 5 Ix equals to negative I1. Ching ching. Alright. And then you put 5 multiplied by negative 1.58. Okay. And then you do 5 times negative 1.58. You will be getting negative 7.94. Yay! Is it done? Tak lagi. We have one more to do. Therefore, I Norton equals to VTH over RTH equals to negative 7.9 divided by 1.58. 1.58 equal to bahagi 1.58. Dapatlah balik jawapannya negatif 5. Volt. Current lah. Negatif 5 ampere. Alright, so begitulah dia the solution, okay, to your question, for your quiz 2. Alright, so hopefully you're able to see. So don't worry about your quiz. I know a lot of you will have different IX, or maybe you don't have IX. I'm just going to follow your IX, whichever you follow. But I hope you can watch this video and understand the process of getting the VTH, RTH, and I Norton. Alright, thank you all.